So we're going to walk through the frequently made mistakes that I observed when reviewing assignment 3B. And a couple things to note. Please make sure you document your code. If you don't document your code, it's not going to be reviewed. Feel like I'm a broken record, but people keep sending me code that's not documented. Next thing, a lot of challenges with this particular assignment. This is probably the hardest assignment in the course because it's got a bunch of moving parts. So let's break it down and start by taking a look at issues with the fair semaphore CO for condition object implementation. The first thing, don't initialize the field in the field declaration. Instead, initialize it in the constructor. Some people were doing it both places. That's definitely wrong, but it's better to do it in the constructor. And in that case, you should make your fields private. You should make your fields private and final. Take a look here at the constructor. This particular constructor's got a problem. It doesn't initialize the wait queue, so the code will fail horribly at runtime. This particular implementation did not have this like that. It basically just looked like this, and therefore wait queue was not being initialized. I have no idea how that could have escaped your notice because you should have gotten all kinds of failures when you ran the tests, but make sure that you initialize everything properly. Moving right along, here is the acquire uninterruptibly method. There's a bunch of issues here. The main issue with this code is it doesn't fulfill the specification above. The specification above is very explicit in asking for specification. There we go. This implementation here does not fulfill the specification above. You should be using a loop, not recursion. Using recursion can cause all kinds of problems. Likewise, you need to set a flag here and test that flag after the loop exits rather than doing what's being done there. This will, again, cause all kinds of problems. Similar issue with acquire uninterruptibly here. This uses break. It should use break. It should not use return. So what you want to do is break after you successfully acquire the lock, and then you go ahead and check for the interrupt here using a flag, and then set the interrupt status appropriately depending on what the value of the flag says. A little frustrating because I had actually gone over this in class last week, and I posted it several times, and people still did it this way, so I'm not quite sure. You need to make sure that you're paying attention and watching these videos. We don't just do them for my benefit. We do them for your benefit so you can get your code right earlier, and it saves a couple iteration steps. Let's now take a look at some issues with try to get permit. So first of all, a number of people did this for some strange reason. You don't want to duplicate code that's done by try to get permit unlocked. The try to get permit unlocked method does this, or should be doing something along these lines. And so you just need to call to that. And you definitely don't want to be calling try to get permit unlocked twice. I'm not quite sure why it's called in two places, but you want to make sure you only call it once, and you do some other stuff here based on the specification. Here's another issue with try to get permit. This code is always unlocking the lock, which is completely wrong. You want to only unlock the lock if you manage to get the permit unlocked, because that means you're done. If you don't manage to get the permit unlocked, you don't want to unlock the code because you want to have that lock held when you get into the wait for permit method. Down here, yet another problem with try to get permit. This is grabbing the lock and then always unlocking it by using the finally portion of the try finally block. That clearly doesn't fulfill the specification above. You only want to unlock it if you manage to acquire the permit. If you fail to acquire the permit, then you want to leave the lock locked. So that's incorrect. Down here, yet another problem. This is also, again, duplicating code, and it's always unlocking the lock, which it shouldn't be doing. You need to be very careful how you do that. So make sure you don't duplicate the code, and make sure you do the right thing with respect to what happens. And then down here, let's take a look at some issues with try to get permit unlocked. So this implementation doesn't fulfill the specification above, which is going to be checking for two things: whether there's already something in the wait queue, and or if there are no permits available. So that's how you can get the lock. If there's something in the wait queue or there's no permits available, then you can't get the lock. Otherwise, you can get the lock, or you can get the permit, and that should be a flag to decrement the permit appropriately. Some more problems here. I don't know what was going on in this case, but don't be calling wait for permit inside of try to get permit unlocked. That just makes no sense whatsoever. and should fail the tests quite aggressively. And this code, you don't want to be calling acquire inside of try to get permit unlocked. That also, again, just makes no sense. So don't write code like that. Read the specifications carefully and do what they say. Don't make it more complicated. This code is also, I'm not quite sure what the heck is going on here, but try to get permit unlocked is just supposed to check a couple of conditions with the lock held, and definitely not supposed to go into a loop. It's not supposed to call a wait. That will also fail in very aggressive ways. All right, now we get into the method that most people had a really hard time with. First thing, make sure you go and read the Tom Cargill paper and make sure you watch the videos about the specific notification pattern, and also the videos that I posted in Piazza that show how to implement that pattern in the context of this assignment. And that really walks you through kind of step-by-step what you need to do. This code is just completely wrong, but leaving that as it may, people continue to call unlock just randomly in weird places. Always, always, always call unlock in a finally block. Unfortunately, it's not possible for us to check that with the testing framework that we have at our disposal, but I've said this now pretty much every single assignment, and so it's a little bit disconcerting that people still keep doing it a different way, and you're just hurting yourself in the long run. Let's take a look at some other issues with wait for permit. There's no need for this atomic Boolean local variable. This code is also very incomplete, doesn't implement the specific notification pattern correctly. Please go back and read the Tom Cargill paper and then watch the videos I posted to see what to do here, but this is wrong. If we come down here, then, and one other reason this is wrong is that you won't need to call lock on the monitor lock because it should be held from the call to try to get permit, which will keep the lock held if it's unable to acquire the permit. Down here and wait for permit, this lock, the lock is not being released correctly. This lock is being called in the wrong place. It should be called earlier. And this code is structured incorrectly. It's just confused. I'm not going to try to debug it in great detail, but it's definitely not what you want to do. Once again, see the Tom Cargill paper for tips on how to do the lock ordering properly, as well as take a look at the videos that I put out that explain how to do all this stuff. And these tests, these won't pass the test. So I hope they aren't passing the test. This monitor lock should already be held at this point if you implement try to get permit correctly, so you don't need to do this. Don't be calling remove here, since if add were to fail for some strange reason, you don't need to remove anything because it never got put in the first place. And then the wrong lock is being released at this point. You really need to be releasing the monitor lock, which was held when you got into this method, not the waiter lock, which I don't even know if it was acquired in this implementation. This code is too complicated. You need to just use a while loop instead of a do while loop. This has got more checks than you really need. And then you need to check carefully for the interrupted exception and handle that case correctly. Once again, read the Tom Cargill article and watch the videos that explain how to do all this stuff. And this is the wrong lock to release here. Don't unlock the monitor lock. That should have been unlocked much above in some other parts of the code. This has also got implementations wrong. This needs to be moved before the try block. Again, there's no easy way to check that in our unit test cases, but you should not be doing locks within try blocks like this. Always call unlock in a finally block. Please do that. Again, we can't check it automatically, but I keep having to raise it over and over again. So you really should be learning how to do this properly yourself. This needs to be called in a loop. You almost always want to call the wait method on a condition object in a loop in case it gets interrupted for some reason. And there's no need to check if m available permits is less than or equal to 0. I'm not sure what that's doing there. This code is not handling the interrupted exception at all, much less correctly. So that's wrong. This code doesn't belong here. It doesn't belong in the finally block. It belongs in the interrupted exception catch clause. And you always want to release the lock, but this is the wrong lock to release at this point. This lock needs to be released up in the catch clause. Down here, you want to go ahead and unlock the waiter's lock. So again, you got to read the paper and watch the video carefully to see what I'd show how to do this. Now let's turn our attention to release. A lot of problems here too. you need to refactor the code so that the lock isn't held for the entire duration of the release method. If you do it right, then you can have the monitor lock held only for a short period of time, which is really a good thing. Down here, this condition is not being used properly because you have to hold the waiter lock when the condition is signaled. Otherwise, you'll have all kinds of strange problems. Once again, don't hold the monitor lock across the entire release method. You don't always have to increment available permits. Only do that if you have to under the right conditions. I recommend using poll instead of isEmpty and get first, just a little cleaner. And you're missing something important here. You're not setting the mReleased field properly. So that's also missing as well. Yet another problem with holding the lock too long. That's kind of a recurring problem. You can, if you hold the lock properly, you can move this code out of the try finally block to avoid having to hold mlock when you signal the waiter. That's kind of the secret sauce for doing this properly. And you don't need to do this at all. You don't need to remove the first waiter from the wait queue. That should be handled earlier. And you always call unlock in a finally block, just not randomly by itself. And please refactor your code so there's just one place that calls mAvailable permits. And then last thing that I saw in the FAIR Semaphore CO implementation, make sure you don't lock the lock upon the creation of the waiter nested class. That needs to be done in a different part of the method under a different locking protocol. Okay, so that is the end of the issues that I saw with the FAIR Semaphore CO implementations. Let's now turn our attention to the Palantiri Manager implementation. So first of all, again, we went over this in class last week. A whole bunch of people apparently paid no attention to what we covered because you all kept the code in here like this. This code is just plain wrong. It contains race conditions. It doesn't fulfill the specification. Please read the specification carefully. It tells you exactly what to do. Do not use streams here. It does not work. Your code will have all kinds of bugs. Now, again, I think the latest version of the unit tests that are coming out with assignment 4 actually will flag this particular mistake, but you got to pay attention to the videos that I give because I do them for a good reason. This code needs to be inside of a nested forever loop, and that's because it may not get what it wants when it does this loop here for various timing reasons, because we don't have any lock that's protecting the entire Palantiri manager. In this case, you don't need to use the get method. You can just use the 3-parameter version of replace. That is exactly what it's there for. It's there to be able to do these atomic check, then act operations. So you don't need to have this extra call to get. It doesn't give you any win. This, again, you need to put this inside of a nested forever loop or a while true loop. Please don't use entry set, use key set instead of entry set. And again, this code is unnecessarily inefficient. And it's also, this is also just inefficient. So you can get rid of that. If you use key set, it'll be a little cleaner. You don't have to use the get value, get key accessor methods. Yet some more problems with acquire. For whatever you do, don't release the semaphore. That defeats the whole purpose of having the outer while loop. I'm not quite sure what the thinking was here, but definitely not what you want to do. You don't want to release the semaphore. You never want to release the semaphore in acquire. That'll be a big problem. Down here, remember that replace can return null. So make sure you check for that case. This, again, was something that we've gone over, I think, in almost every single feedback I've given. It's been in the frequently made mistakes for every single video. I think it may actually also be in one of the quizzes. So I'm not quite sure why people keep recreating mistakes, especially when they did them correctly in the previous assignment. So make sure you take a look at what you did before. And if I didn't have any comments about it, that's probably a good sign that you can reuse something along those lines for the next assignment. Don't go and reinvent something incorrectly. This is a good example of this. This code is incorrect. It's not checking the return value from replace. It's not conditionally calling release. Ironically, the person had that correct in the previous solution. So, I shouldn't be in a position to have to go back and find bugs multiple times. You should make sure you correct those things yourself. This code is not correct, but it's not commented. So I'm not reviewing code that's not commented, but it's not correct. And whoops, it's also in the wrong place. It should be up earlier. Let me go move that to where it belongs. this code up here goes back with this piece of code there. This code is also incorrect. You need to first start by checking to see if the Palantir is null and bailing out if it is. That, again, was something I think that was done correctly in the previous solution. So why it was changed to be incorrect is somewhat of a mystery, but make sure you're reading the comments carefully and then, more importantly, thinking about what the solutions are. And then, again, you need to make sure you check the return value of replace and take the right action, just like you did in the previous solution. So, again, it's somewhat frustrating when I have to go back and find bugs again that we've gone over many, many times. You really need to put the effort in to do this right. It defeats the purpose of these reviews if I have to keep redoing them over and over again. Never call the lock inside the try portion of the try finally block. We've talked about this multiple times. Just don't do that. And also, whoops, this also belongs somewhere else too. This belongs back up in the other release method. So let's put it back up there. And again, you need to make sure that you don't hold the lock for the whole duration. And there's some things missing here that you're not actually signaling anything. So lots of problems there. So as you can see, a lot of people really struggled with this program. Those of you who did well, great job. It's not the easiest thing to do, but make sure that you watch this video. Make sure you take a look at my comments. If you have any comments or questions about my comments, feel free to reach out, and make sure for certain that you fix all these problems before you submit assignment 4, because we have more thorough unit tests now. And so stuff that may have somehow slipped through the unit test in assignment 3B should be caught for assignment 4, and you will lose points unnecessarily. And most importantly, make sure you get the code right and kind of think about it. So it's a very, very cool pattern. It's a very cool implementation, but it requires a bit of thought.